Hey, thank you very much, for being here. So my name is Helena. I'm from Verisense. The original speaker, Dr. Yan Xiao, has some personal engagement, so couldn't make this session. But I'm very happy to be here. So today I'm talking about Verisense, a FHE-enabled validation as a service platform. So when we talk about validation as a service, or a couple other contextual concepts, and then, I'm talking about like how FHE enablement happens in our systems. Okay. So first of all, what is a Verisense, right? And then the context of restaking the ABS. So Verisense is basically a validation as a service network that from restaking. So people may often ask, seriously, what is a restaking? Because I spoke with many investors and then audience, right? And often I get these questions. Restaking, isn't that just a fancy term of DeFi again? Find some way to get more rewards, right? No, no, no. We think it's a very different. That's just the very kind of a early concept of restaking. It's just because the eigenlayer is not doing really a good job to really prove their vision. So in us, we think restaking is one side, of course, here that pulled all the collaterals to supply for security origins. That chapter has been already clearly demonstrated by a couple players like Eigenlayer, Symbiotic, Karak, possibly Soul Layer in the Solana, right? However, this chapter here, basically that needs to be, after we pull together those collaterals as a security origin, how do we actually find a mechanisms that works as a crypto, like a critical components to restructure and redistribute the security origin and make sure those security origin is provided to the ABS towards their needs. For example, different degree of the decentralization, different security needs according to their different security affordability, right? According to the different life, different stage of their life cycle. So this part is missing. That's why so far the restaking story is somehow just kind of like stalled there. Like nobody knows what's going on, right? So Verisense comes here to just resolve these issues. We basically built these components, all right? And then we already figured out a way to onboard a bunch of ABS that you won't be able to see in the Eigenlayer ecosystem. They are often, not being very well served in the general purpose L1 blockchains like Ethereum, Solana. Okay, so I think I basically just talk a little bit about the current problem is that restaking is very much right now focused on supply side, not at the demand side. We need to find a way to finish the story and by onboarding all kinds of ABS, validate the business model, and especially those ABS needs to be paid ABS. But who could be paid ABS? Let's think about that. Eigenlayer onboard bunch of networks, but they're not paying because there already are some existing network-based apps or services. And then when they onboard Eigenlayer, they're more for like a marketing purpose. They're not really looking for a working infrastructure. But only the applications or networks or services are not able to serve very well by the general purpose L1, most likely like most particularly EVM equivalent L1 blockchains. Then there possibly could be find a new restaking infrastructure like for restaking as a shared security origin, right? So this is how we try to find the paid ABS. So then people might ask, what's the difference between the shared security, right? Isn't that, all the L1 blockchain already about shared security? Why do I need a restaking for shared security? That is because we think that, the difference is that a homogeneous network versus a heterogeneous network. If we look back here, right? Look at the L1s, it's all layer structured. That means you shared the security for sure from the underlying infrastructure like Ethereum. At the same time, you also inherit the limitation. But if we want to really break the limitation of Ethereum, for example, like get rid of the whole smart contract, which has nothing to do with the smartness, right? What do? Restaking is a possibility to like resolve this issue, we basically like able to parallelly support all kinds of heterogeneous networks. It could be EVM equivalent networks. It could be a actor model based networks, or it could be even like a Mona type of new blockchain networks, right? That all works under restaking. But the concept is that we need to have a make component. This component works. So now let's look at Verisense architecture. So we basically just like work with restaking partners. Right now we're already working with Solana, the Sol layer, and then Karak, Symbiotic, and also possibly down the road with Eigenlayer. And we already kind of like build these components that are able to onboard all kinds of AVS. So this is our architecture. It's quite a crossing eyes. And then in those smaller networks, we basically use all sorts of like FHE enablement to add on the security layer. Okay, so I will explain the implementation a little bit, but let's first look at the overall framework. In our system, we have a hostnet and a subnet. Hostnet essentially just like a POS networks. However, for the restaking networks, we actually allow all the operators to work as multiple actors or multiple smaller networks, and then to support those AVS operation. And then that basically forms the subnet. Okay. And then in our system, since today, we're not in the restaking concept, right? We're more at the FHE Summit or FHE type of a project. So we're gonna just talk a little bit more about how FHE is enabled in our network. So we basically like use some of the applications for VRF or blind voting, just to add on the security, because often people might challenge it. All right, seems like those subnet concept works, but then it's a smaller network. How do you balance the security measures, right? At the same time, keep the consensus lightweight. So this is how we use FHE to add on the security layer. Let's look at the first VRF. I may probably come back to my computer here. So we know that in the traditional VRF workflow, right, a user provides a C value, and the node calculates a random number using its private key and provides a hash proof. Simple. Typically, nodes and user cannot collude, right, ensuring the VRF effectiveness. However, in our scenario, participants, which is a user, are the node themselves, so leading a high risk of collusion since user and nodes are the same entity, right? So then here's what we do. In the distributed framework, we use BOS as a threshold signature scheme. However, using BOS as a VRF poses the problem that the last signer can gain an advantage by receiving all other signatures beforehand, right? So for example, if the last signer finds the random number unfavorable, they can choose not to submit their signature. So we address this issue through a two-round computation process. First, each node encrypts its own random number. In the second round, all nodes compute the XOR of their encrypted value, and the result is decrypted using threshold decryption to obtain R. So which serves as a random number. So that we adds one layer. Okay. Come to the monitoring. So then we actually kind of like implement a very interesting consensus using the two-layer network structures, right? The first layer hostnet is just using the default consensus baby and grandpa from Substrate framework, which is implemented by Parity Polkadot. But then at the AVS network, we actually implement this Mona ring. That is a shrinkable or expandable consensus that we designed this way to meet the needs of the AVS. Imagine those AVS could be very, very different, right? It could be a new virtual machine. It could be a decentralized TikTok. It could be a FHE implemented or enabled application. It varies hugely in the format, and it also changes a lot in terms of their security needs. Some AVS probably just need 3 nodes to start as a, let's say, course demo or a pet project of kids. Some are more matured ABS. They are commercialized projects, right? They need a larger degree of decentralization. So which means they might probably want to start from 21 nodes, 50 nodes. So then, we need a consensus that being able to shrinkable or expandable depending on ABS needs. That was Monaring is mostly due. So this is basically a lightweight consensus scheme for final consistency of ABS application. It's ACT model based. So let's take a look at the Monaring. Here, this one. So Monaring consensus algorithms applied in every subnet independently. Okay, every subnet has its own ring network type of topology. This is inspired by IBM token ring protocol. Although they're in different fields, but they're facing same problem: how to decide the global sequence of a decentralized network, especially a kind of a heavy load network. So a node could update the state only when it receives the token from the successor. Okay. So that token, ring, a token ring type of network is a type of like a local area network where, devices are connected in a logical ring topology. This network design developed under IEEE specification uses a token, a special data packet, right, that circulates around the network. So only the device holding the token can send a data and, process the local workload. That a method, prevents collision that might occur in multiple devices try to transmit simultaneously, as you can see from this network, right? So this is our Monaring. When a node receives the token, as I mentioned, right, it should handle all events with that token, then update events from a request that it receives. All unconfirmed requests will be in the local pending queue of a node, similar to the transaction pool of a blockchain. So once the node completes its pending request, that should put all of them into the token, or a container with that token and the signature and its voting results hidden by FHE technology on each batch existing in the node in the token. And the Verisense runtime finally will decide the state root of a subnet when it receives a normal transaction, no matter who submits it, since the runtime could decrypt the voting results. So furthermore, let's take a look. That's the first route, right? Let's see the actor 1, which is essentially an instance of a node, right? Take the token and then finish some work and attach it with a token, pass down to the next station. Next one, do the same thing, finish the local workload, and switch to next one, right? So then once they finish the one round, that means this finalized and submitted this kind of a local consensus to the host net, which would be permanently finalized. Okay, so then the second round starts. So that's quite simple, right? This is the whole network look like that, right? Because I keep mentioning the host net and the subnet. So each node participating Verisense essentially works as the host net. But then because each node can run multiple actors, that essentially become the different subnet for all the ABS. That's how we're able to support various ABS, and each ABS may change, may request for a different degree of decentralization. That's how we're able to implement the consensus, shrinkable or expandable, according to the growth of the ABS or the affordability of ABS. This is some simple implementation of write and read actions. I don't think we probably need to talk a lot. So let's just go to the next one, the how to implement FHE into a game theory. Especially we implement a blind voting kind of a encrypted interface using some like open libraries. Because people often ask this next question that how to design a slashing mechanism for restaking in Monaring. We use a game theoretic-based scheme and make the consensus more secure by transforming the perfect information game into a imperfect information game through FHE blind voting. What does that mean? We inspired by VE33. So this idea, it came from the VE model, which is proposed by CurveDex. The three-party game theory model showcases the valuable insights into the action users can take to achieve the best outcome. This model clearly outlines a range of actions that can lead to beneficial results, such as staking and bonding, while also highlighting the potential negative impacts that the selling can have on both the user and the ecosystem. So there are multiple different outcomes from three-party users in game theory, right? When they bond, stake, and sell. So the best possible outcome for both the user and the protocol is this guy here, right? So that achieves the best results. However, because it's a perfect information game, that means everybody sees everybody's action. So once somebody sees like a negative results and then they start pulling away from the game, that essentially turn into a negative flywheels. So then quickly you will see this one sliding to this one that causes the fail of the game. So how do we avoid this? Very simple. Let's wrap up the results so that everybody doesn't see everybody else's results. So you basically vote based on your own decision and best judgments, right? So that's how we implement this. This scenario clearly can be naturally migrated to the role of restaking, right? For example, the restaker corresponding to the role of staker and operator who participated in AVS as a participant also enjoys the Verisense rewards. But if you have a malicious behavior, then you will also correspond to the punishments, right? So the Nash equilibrium point of the three-player game has to be determined to ensure that everyone opting in without malicious behaviors. That means, we basically find a way to keep them stay here, okay? Because if people cannot see what's going on at this part, at this part, at this part, so they won't goes down to here. I don't think, we'll talk a lot about why VE33 fails, because we already observed this, right, a couple years ago. But then maybe just, quick like a context that VE33 model reaches 200 million TVL within 1 day at the time, but it fails after a few months later. It's all because that once that, one person triggered those kind of behaviors, everybody follows. So here's what we do, voting games, right, in Verisense. In our voting mechanism, each voter makes a strategy, sigma here, right? And then to ensure security and privacy, this decision is encrypted before evaluating its payoff through homomorphic computation. The Nash equilibrium needs to be found by calculating the corresponding payoff value through a LWE-based MPC. So this means that all strategies remain hidden until the final computation is completed and the results are decrypted. By doing this, so we transform the process from a perfect information game to an imperfect information game, especially at Bayesian games. So this approach ensures that no decisions are exposed prematurely. So this is a little bit the payoff functions. You can find this in our research paper. Just try to search the keywords Monaring. We define the general form of the payoff function here. So we propose a model based on the Bayesian game, and then which directly determines the final strategy by a prior that is a payoff here, right? In this model, the likelihood would be equal to 1 or uniform sampling if after using FHE. So that's kind of, this is our payoff function here. Reach to this number here, best strategy. So we find the Nash equilibrium by maximizing this this number here, this guy, and then our goal is to find its corresponding Pareto optimal. This is a function optimization problem, which we will not elaborate here. If you interested in these details, you can check out our paper on the Verisense website, which has a detailed in description. So I actually have a simple demo here that shows that how we use this whole infrastructure able to support all kinds of application. So this application is a decentralized forum with a decentralized AI agent. Because we all know that the most of blockchain is a passive, which means you cannot initiate the data input output. You cannot access the decentralized database. You cannot do lots of things. For example, running some queries. Then we are able to create a network that allow those simple tasks. So what does that mean? It means a few things. We finally able to use a flexible way, not disturbing the existing interest layouts of all those major L1s. At the same time, easily extended an arm to support all kinds of applications that the general purpose L1 blockchain is not able to serve well. For example, large scale Web 2 social applications. Let's say decentralized email, decentralized Notion, decentralized TikTok, decentralized Facebook, right? Or decentralized social forums. The second thing would be like a truly decentralized AI agent. In this demo, you will find that we actually, first allow a person to use our true decentralized network to post something, and then a decentralized AI agent would be directly initiate a OpenAI API call, and then reach the consensus, and then post the summary or whatever, the funny answers in the posts. Try to be like, sometimes it could work as a summarize the whole long post, or sometimes just try to being troublemaker, say something, ironic, or say something silly. Or sometimes you could just use this AI agent to being a really helpful assistant, right? By providing relevant context information. So this is a little case study that shows that how powerful that restaking for shared security could be if we play this game correctly. We also recently find another interesting case study, which is a decentralized short drama. What does that mean? It means that a few group of friends write up your own story, and then write up your own scripts, and hire your own cast and crew, and shoot your own videos, and put them into chop them into a 5 or 7 minutes short drama and upload it, and people laugh at it, people can vote on it, and then once the heats reach a certain threshold, it'll automatically launch some fan tokens, something like meme coins, and airdropped to their community, right? This type of decentralized YouTube or OnlyFans application now is able to be supported in a true decentralized platform through AVS by restaking for shared security. Yeah, and then we recently find out that this short drama application announced that they got a top IP, celebrity IPT from China. This is a super famous top hip hop celebrities with 40 million users from China. But then he is looking for a decentralized OnlyFans platform for all kinds of compliance reason from China. Now, Verisense would help him to reach this goal. So we have a very strong confidence that with Verisense, we're able to validate the business model of restaking and finish the story that the Eigenlayer started but wasn't able to really finish. So that's Verisense. Thank you very much, guys.